get started. How about that?
Great. So I'm ready as soon as you see a web page that says ScottMarks/WeddingCapRain.
That would be it. I can see that.
Okay, great. So what I wanted to share was Git and GitHub as tools for doing source code management. And these are tools that we're using right now in our capstone project. I'm no expert on these, so if anyone on the phone has used these extensively, you might know more than me, but I've come from a software development background, and so I have experience with various other source code tools, and I've enjoyed getting to know Git and GitHub, and they're things you seem to hear about, particularly in the open source world. And I feel like some of the fellow students I've interacted with haven't come from software development backgrounds, so I thought it might be helpful to just cover a little bit about source code control and then these tools in particular. So Git is the name of a software-based source code control tool, and if I need to go into that briefly, the reasons those are valuable is they help you keep track of changes to code files, bundle things up together in releases, and so forth. And so it's just really helpful to do version management as you're working on a project, and it gives you kind of a safety net. If you make mistakes, you can go back easily, and then it's especially important when you're collaborating with other people. In some cases, you might trample on each other's work or each do work that conflicts, and using a tool like this can help you figure that out. I guess there's a tool called Git, which is a piece of software you can run locally. And then there's a website called GitHub.com. And they're related but a little bit different, and I wanted to touch on both. I found a great overview presentation, quick introduction to Git on SlideShare if anyone is interested. And I'll just talk a little bit here about some concepts that are helpful. The way source code management works with Git is you have some sort of a public repository you work against, and then you have local repositories. And so each developer would have their own complete copy of the repository they work against. This is the unique thing about Git. If people are familiar with any other source code tools like CVS or PVCS, they work a little bit differently, where you have kind of a temporary local copy, but there's really just this main copy. Git is a little different. You have an entire copy, and that's pretty unique. Git was originally created to work on the Linux kernel. So Linus Torvalds really promoted this use, and it was a way to let developers all over the world collaborate more efficiently. So it's worked on some pretty big projects, but I won't go into great detail. There's a whole set of commands you could use. These are kind of command line versions of Git, and there's some other tools I'll show in a moment. But the basic idea is each developer will do what's called a clone. They'll create a total copy of this main repository. So this might be a main project. In our case, I'll show an example in a moment here. This would be our main capstone code base here, and then each of the people on the project has created their own local copy of that code. And then each person can go about making changes and adding files. And so as an example here, they show there might be a original change 0, they're calling it, and then another change 1 in the main repository. And then when each developer pulls it off, this person creates a change number 2, this person creates a change number 3. They can continue to pull down current copies of this main repository to their local machine where they're doing work to get it current. And then when they're ready, they can push their changes up to this main repository. And this is where it starts to get interesting, particularly with Git. So now this other developer can refresh their local copy from this main repository, and now they have their untouched changes, but now they have the other person's changes, which I'll be able to see. I'm going through this quickly. I'll show more visual things in a moment. And they can merge those changes in and then push them back. And I'm going to jump ahead a moment here. And hopefully I haven't gone through this too rapidly, but what's interesting to show here, and again, this is where Git is unique from other tools, and it gets a little complicated for some people, so I'll kind of gesture to that here, and people that are interested might want to learn more. But when this original developer who made some changes pulls down the refreshed copy of code from this main repository, again, they get an entire copy of all the branches and merges that they've done and other people have done. So they get real total visibility and they have their own safe copy to work against. So that's kind of a quick conceptual view. The way we are using it on our capstone project is we've created a central repository, and then we each have local repositories that we're working against and we can commit changes up. So here's where there's a few different ways you can interact with Git and GitHub. So we happen to be using this website called GitHub, which is really a hosted version of this Git software version control system. And so this is my web-based copy of our project. So this is my Scott Mark account, and I have this Wedding Cap Rain project. And here you can see the different files and folders in our project. So this is kind of a web-based copy, but then I tie a copy on my local machine up to that copy. So here I am in RStudio, and I don't have too many files open over here, but you can see there's Git integration built right into RStudio. So this here shows you the staged changes that I've made that I have not yet sent up to my web-based GitHub repository, so I can kind of keep track of the changes that I've made and commit them when I'm ready. There's also a command line version of Git. I'm a little bit more of a command line person, so you can use these commands on the command line to type in and see what files still need to be changed. You'll see this list here is the same as this list here. There's also a desktop tool. So this is the graphical user interface version of Git. And a lot of the folks on our team like to use this version. Again, it's more graphical. It shows you the files. These are the files that I've made changes on locally that I have not yet sent up to the website. I can click through each file, and it shows me over here what the changes I've made are. And then it also shows me different versions here in kind of a graphical view. Dave Hurst is on our team, and he has the main master repository. I can click over here and see some versions that Dave had committed earlier, a few days ago. And again, kind of nice. It highlights for me what specific changes he's made, so I can kind of catch up on what he's been doing pretty easily, and then commit my own changes. A couple other things I wanted to point out. So that was a little bit about the system known as Git and how you use it to change files. Again, if you've used version control, it might be similar. There's a couple subtle differences. Again, that complete copy of the repository is different and has some implications. If you ever use or hear about GitHub, that adds some additional dimensions to it that I wanted to cover briefly. And two topics you might hear about if you ever hear about GitHub are forking and pull requests. And so as an example, I'll go over to Dave's repository. So this is the main project repository that we're all working against. Dave created this. And when I started doing my work, I went up here and clicked this fork button. And what that does is it copies Dave's repository over to my account. And so now when I go to my page here, you can see it shows me that it was forked from Dave's copy, so that's just sort of a trace. But now, again, online on the GitHub website, I now have my own protected copy to work against. So I can work against this fork as much as I want. And it's just me doing that. And so you'll see that a lot if you go around and look at GitHub repositories. You'll see people are forking them. And it's a little bit of a social dimension to this. It's kind of fun to see how many people have forked a given repository, and you can see what those people have done with it and so forth. Then the last topic I'll cover is when you work this way, it would be possible for me to just have my local copy work directly against Dave's web-based repository here. Doing that, it's a more simple route, and it's closer to how a lot of other version control systems work. But I would say what's more common in kind of the open source world and what you hear people talking about doing is this forking method where you fork that main repository and you have your own copy. When you do that, you use a thing called a pull request to push changes back and forth. And this is what makes it a really distributed and powerful version control system. It's kind of a formal way of requesting that changes you've made in your local repository get pulled over into a master repository. And so the way my workflow works is I do my work on my local machine here in RStudio. I commit changes to my local laptop's repository. I then commit them up to my website's repository. And then when I'm ready, I go through these steps of creating a pull request. So I'll click this button. It will automatically show me what's changed. And then when if I click this button, it will basically send all the code over to Dave's repository along with a message. So Dave would come in and see a message, and he could click a button, and it would automatically merge all those changes together. So a lot of it happens automatically, but with some notifications. And again, it's kind of a unique way of doing version control across a distributed network of people. It's perhaps a little bit overkill for the size project we have here, but we thought it'd be a good opportunity to learn the tool and experiment and get to know some of these things a little better. So I'll wrap up there.
I have a couple of quick questions, but does maybe anybody else want to ask a questions first? Oh, I guess that means me then. Okay, the first question I have is, does it require any special, okay, let's assume I want to use GitHub. I just go to the GitHub website, or do I got to install stuff? What would be the procedure if I wanted to go, you know, I got 5 guys and we live all over the world and we want to start using this tool. What does it take for us to start using it?
Yeah, great question. So you would want to go on to the GitHub website and you can create a free account, and so that will get you a place that you can store your repositories online and let you join teams and things. We happen to have a private repository, so that's a little team-based concept. You do need this local Git software installed. If you have a Mac, Git is already installed on Macs. Otherwise, through the GitHub website, you can download this GitHub desktop application that I mentioned if you want to use that environment. Otherwise, again, if you have the Git software, like command line software installed, I believe it automatically integrates with RStudio. So a lot of the development environments will have Git integration built into them. But yes, you'll need some additional software. It's freeware, open source.
So RStudio, if I have RStudio, that will be good enough for doing this?
So what I believe you need, I think you at least need the command line version of Git installed, and then I believe it integrates with RStudio.
Oh, I see. Okay, and I can get that Git at GitHub?
Yes, I believe you download it through GitHub. Again, I apologize. I'm on a Mac and it came installed, so I didn't have to go through that.
Okay, not a problem. I mean, that answers some questions. At least I can do that. Now, the other question, how hard is it to learn this stuff? You clearly knew this stuff well, but I'm guessing members of your team didn't know it. What was their ramp-up time for this?
I think a couple other team members are on the call, and if we have another minute and they want to chime in, that might be helpful. We did some kind of intro calls, and I talked people through it. We also made a decision to work in this more simple model, and it seems to me like it's working. I'm able to pull down people's changes successfully. There is a little bit of a learning curve, and it does require, you have to think a little bit differently about your work, but it's also, I think, one of those trade-offs of there's a little bit of a hump early, but it can potentially save you a lot of headache later.
Mm-hmm. So, but the point is, the people were not super familiar with it. They weren't totally lost. They got up to speed relatively fast. One more thought, and this is also, keep this in mind for the 411 students who have me for 498. What you guys might want to do is something like this. Remember, it's not just doing your project. The other thing you guys got to do in 498 is give value to the corporation. This is something that could be of great use to a company if they don't have any software repository protocols in place. Being able to say, hey, look, there's something free out there and we can do this. This is something that that the boss would love to know about. So make sure you put this in your report and try to get and put this in as another benefit of your project, because it's one of those things that can get you some more points in the class, but in the real world, being able to introduce stuff like this gets you a lot of visibility in a corporation. So make sure that you take credit for all the benefits you bring with a project, not just that I got a project done and I got a model built and I'm done. Everything, all the ancillary things are valuable to a corporation. Make sure you claim credit for them.
Yeah, I'm making note of that. Thanks for that suggestion. That's great.
Yeah, I have a question. Did you submit this model in Kaggle?
Sorry, I didn't hear that.
Did you submit model in Kaggle? This how much did it rain?
Yes, that's the project we're doing, is the How Much Did It Rain 2 project on Kaggle.
Yeah, how much did you score on it? I just want to know your, I mean, if you can tell. Because I submitted my model, I scored 36. That was my rank.
Okay, that's a good question, actually, that I haven't done the submissions. Other team members have done the submissions, and I don't know exactly where we rank at this point. There's a very, very tight distribution. I think it's down to like the thousandth of a millimeter that's differentiating the leaderboard at this point. And so I forget exactly where we rank. I think we're a little high.
Yeah, it was very tight competition, I mean, when it was running.
Yeah, it is. It really is.
We've been building, we've really been kind of doing EDA and have not built a model. We've submitted a couple just to kind of understand the metrics, but we haven't really built a model. So we've taken some of the fixed-line Kaggle scripts and modified those, and I don't remember where we were on the ranking, but yeah.
I would like to share that with you because when this model was active, I ranked 36th. I submitted alone, which was a top 10% model, but I would also like to know your approach.
Was that for Kaggle Rain 1 or the current Kaggle Rain 2?
No, that was How Much Did It Rain, the one that ran in Kaggle sometime back.
That was the first one, yeah.
The first one. Yeah.
Yeah.
So this one's active right now. But
this one is active.
Yeah, they're using it for metric now.
Okay, if you can share your thoughts on that one, that would be great.
Yeah, we can take that off the call here. I guess if you want to get in touch with me, this is Scott Mark, or else Dave Hurst was the one just talking.
I will.
Thank you.
And see, there you go. And that's the kind of thing that in school they discourage, but in the corporate world, like 498, I love that you're getting information from somebody else, because I'm not paying for it now. You know, somebody else is I'm getting benefits from somebody else's work, so that's a good thing. So anyway, go ahead. Does anybody else have a question, or we'll move on to the next person? I'm hearing silence here, so guess what? I'm making Scott Mark is now a participant. Okay, Thomas Pritchard or William Kreckler, who wants to go next?
I'll go next. William.
Who's that?
And I'm sharing my first monitor. Let me know when you can see it.
And this is William Kreckler, huh? Yes. Okay, well, you are officially in charge.
Okay, so last time we met, we did the show and tell. Dave Hurst talked about R Markdown, and I had heard of it but not used it, and I thought it was really good. And a related project that's part of R is RShiny. And I'd heard of it before, but I hadn't really used it a lot. I tested the large, but I've been using it a lot more lately. Unfortunately, I can't show you what I've been developing because it's for real work. But I thought that I would walk people through understanding how you do a Shiny application and then show you some of the really cool stuff you can do with it. So Shiny publishes a great 2-page cheat sheet for how to do it. And I'm actually going to use that as the reference. And if you're learning R, there are a number of really good cheat sheets. Like after Dave Hurst had presented, I actually looked up the R Markdown cheat sheets and used those to pretty quickly develop some HTML reference. The difference between R Markdown and RShiny is that R Markdown is static documentation. It generates a PDF or an HTML document. RShiny generates an interactive page with your R code. And it's based off of a couple of key files. I'm going to zoom in on the building the app here. Naturally, it goes slow when I do that. I think I went too far. Oh, wait. Okay, so the core files. Oh, they just jumped to page 1. That's why I'm confused. It's odd how just zooming in can throw somebody off from the context of, oh, that's really odd. It's not showing words. There we go. Now it's showing all the words. That's why I was confused. So there's application.r, which you can just have a name for, like an R file is what you would normally run to run an R project. There's a global.r, or you can have a README file. There's a server.r and a UI.r. The global.r, if you run library shiny to load the package, and then you run the command run app. It's right here in the corner. With the name of the folder that your files are stored in, it will go and it will automatically load first the global.r, then the UI and server.r files. And the global.r loads things that both UI and server need to see. UI loads the actual graphical interface elements, so what does the layout on the page, and then server are the interactive elements for that. And it runs off of a key set of defined parameters. So you have an input, whether it be a menu or a checkbox, and menus a lot of times are used as filters or as a plot, something that you can enter information into, and then it goes through some sort of interaction, like an update, because you pushed a button, or you did a checkbox, or you changed the menu, and it based on a reactive function or an observe event, which are things that you define in your code, it then decides how to react, what expression to run, and then it generates the output that updates. And I know I'm going through that quickly, but the core idea for RShiny is actually laid out pretty well by this 2-page summary, and it gives you all the elements you can do, like action buttons, links, choice elements. You can add dates in. So for instance, like at work, I developed an interactive menu where I could actively filter, and I had linked menus. So say column 1 is menu 1, column 2 of my data frame or my data table is menu 2, so that when data 1, or when column 1 is filtered to only have rows 1 through 10, then the column 2 menu only shows up those items. So those are the kind of cool things you can do, and then it reactively updates the plot you're showing. Now let's show an example. So we go over to, Shiny has these great galleries, shiny.rstudio.com/gallery, and they have all these examples. The one thing you'll not find is an example for how to do interactive cross-linked menus. I need to figure out a way to write that up that doesn't include work code, because I had to stumble through it. But this is an example of a bus map system in Minnesota, I believe. And it's all based off of RShiny. It's using R as an underlying package. And you can click to show, okay, I want to see all the routes, and it'll interactively update the plot you're showing. And it acts just like you're interacting with an active web page content. You can turn off, like maybe you only want to see the northbound bus. So it'll plot and tell you, well, this is where the bus is, and you can change the refresh interval. You can see the list of vehicles running. And these are all based on elements like this would be a render plot. These would be checkboxes, menus, and this down here would be a render table. And then there's other, sorry, wrong link. There's other galleries like you can do more of a traditional scatter style plot where you're doing a slider button to adjust what is shown in the overall plot that's being updated. You can also do delayed interactions. So like, for instance, my work database is really, really large, and I didn't want the plots to update while people were interactively filtering because it would slow down the application. So I actually made a delayed reaction to the plot, so it waits until you're done changing the filters. So that's a very quick, high-level overview of some of the cool stuff you can do with RShiny. And again, it's a package that you can load with R. It's integrated with RStudio. You load it with the Shiny, S-H-I-N-Y library. Question?
Does it do anything other than graphing, or can you, I mean, could you do something else with this, or is it strictly a graphing tool?
So the goal for RShiny is to be an interactive viewing application. There are some extension packages where, so for instance, let's say that I filtered and I got to where I wanted to be. You could export the graph, or you could export the updated table of information you had. You could have it set up so that you select the data you want to be included, and then have it run a model against that subset of data.
So this is free, but there's paid extensions to it that you can purchase.
Correct. So the free, my understanding is the free version runs a couple different ways. You can host your own server if you want to have people be able to get to it remotely. That would be the most complex free way to do it, I guess. The easiest free way to do it is actually the way I've been running it at work, and that's just you download the package and you use the run app command, and it runs as a local host browser application on your local machine. And then there's enterprise level where you pay for it, and they actually have a server, and they specify how many users you can have per month, and they support the server, and all you do is upload the app to their server, and then it runs from there. You were going to ask?
Oh, yeah, I was going to say, so it's got a lot of graphs here. Can I use any graphs in R, or is it strictly ones that Shiny provides?
A little of both. So the limitation with Shiny, and this also comes up with some of the HTML commands as well, and you'll see in the cheat sheet that it shows you all the similar commands on the right like you would expect to get from a traditional web page. And some of these are actually editable with tags like you would have in JavaScripting inside of a normal HTML. You know, HTML, CSS, JavaScript are what a lot of the original web is built around. And you can edit those. The catch is that the interface is sometimes different. Like the thing I ran into with HR yesterday, HR draws a line across the page, and Shiny doesn't recognize, just like Internet Explorer and Mozilla might recognize different versions of the formatting rules, it doesn't recognize all the formatting style rules for HR, so I had to search to figure out which one to use to change the color of the line. Similar things happen with plots. You can create plots inside of expressions, but every once in a while you run into something that for whatever reason it doesn't like that expression. And it usually has more to do with whether or not you're using what's called a reactive element. So you define a reactive element as something that auto-updates with a change in the user interface. And I run into issues with, well, I wanted to use a reactive element, but because I was running my plot function inside of a traditional non-reactive R function, it wouldn't work. It didn't like that. And I just had to creatively think about, okay, how do I program this within the parameters that are allowed? But it does have interaction or direct integration of ggplot2, and I have not done it yet, but my goal is to do interactive ggplot2 where you update the graph while it's there and you can click on it and that sort of thing.
could you send me an email? And also, Scott, I forgot to ask you if you have any slides and what have you for GitHub. And if you send me this cheat sheet, I'll post it for the students as well, if you could do that, William.
Okay.
Okay, thanks very much. I keep seeing more and more stuff from R in these show and tells, and as a SAS guy, I'm wondering if I should be worried.
The advantage is that it's free. Like a lot of SAS has a lot of utility built into it, just like a number of the other pay-for packages do. But if you don't have the resources, like personally, to do that, it's harder to do. Like one of the reasons I went towards RShiny with this project, or my work project, was they came back and said, well, Cognos won't do what you want. We're not giving out any more Tableau licenses for the rest of the year. And I was like, okay, well, I need to move forward. Let's use RShiny.
Do you like, if you had to choose between Tableau and RShiny, which would you go with, or is it an apples and oranges comparison?
I think it's two different user bases. I do not have enough experience with Tableau to give a really good answer, but I would say that the Tableau user base is much more focused on I can quickly develop a graphic, quickly interact with the data, whereas with R, yes, you can potentially do a lot more. You can build in more models. It can be more customized, but that's also the negative. It's going to take you longer to develop it.
I see. So, well, this is very good. I like learning all these new packages. The only thing that bothers me is it's like so many of them. I don't even know which one to learn first. So, getting hard to keep up with the technology. But I thank you very much for putting this in. So,
you're welcome.
Do you have any other comments? Anybody else have any questions here? Okay. Well, guess what, William? I'm going to make you a participant. Okay, Thomas Pritchard, you're last.
Okay. Are we live?
Yes, we are. Ooh,
okay.
Demographics for Latin.
And I'm going to give William Kreckler credit for this because to begin the program, I asked, how can I find free demographics? And he pointed me towards the Data Science Toolkit. I'm not sure, William, how much your background is on it, but in the last 3-4 weeks, I've been camping out on this tool, and I've learned to love it and hate it at the same time. So I wanted to tell you a free demographics toolkit. It is amazing, especially that it's free. It is based on or developed by a guy named Pete Warden. He said these things should be free, so he developed a large server, and this is the link, datasciencetoolkit.org. That site is up and down like a yo-yo. It's been down since last week. It came up, I think, about a day and a half, 2 days ago. Obviously, this last weekend, I couldn't do any work whatsoever, but I'm going to show you a solution for that because I have now got my own data science toolkit running on my desktop at work. So what it basically does is, as I mentioned, it's a feed. You can download your own VM of the Data Science Toolkit. I'll show you the website in just a second. It's about a 22 gig file. I used a wrapper called Vagrant, which basically makes it very easy to wrap it and runs on VirtualBox. So it's all free. And it's also available on Amazon Web Services if you have an AWS account. And by the way, if you don't get one, there is a 12-month free subscription to AWS. You get 750 hours per month. You can spin up Linux boxes, Windows boxes. Not everything's available on the free offering, but it is super to play with if you get into, now, and don't confuse it, there's a data science toolkit, there's a data science toolbox. The toolbox on AWS is actually a Linux box with a bunch of tools, Python, R, and a bunch of other tools installed on it. So I want to show you what the parameters are available on here. I'm going to go back and forth here. Data Science Toolkit has a lot of demographics popped into it, and just some of the parameters you can get from it. I want to see if I can expand this out a little bit. Population density, under 1 year, 1 to 4, 5 to 7. You can get population that are Asian, Black, African, foreign. In our Predict 498, we have a need to demographics to crime in Chicago, and we want to see what is the graphics of a specific area. And so this toolkit is going to prove, hopefully, to be our savior, if you will, for providing decent demographics. With Prism before, it's a fantastic data set, and it's expensive. And marketing companies pay big dollars for it. But I went and pulled this down and basically used this, and it's going to give us a pretty good stab at the entire demographics. Now let me show you the website. If you go there, datascience.toolkit, you can go to this side here. It's almost like it says, scale this server. And if you grab this right here, you're going to download a 22 gig file, and then there's instructions on the internet on how to get that file working. And it literally, when I fired mine up a couple days ago, this is the first page I saw when I hit the website. It's 8080, it's on my own machine, but with R running on my machine, on this virtual machine, it's this website, and I'll show you just a bit how to access this website. It's basically sending it commands. If you scroll to see it, there's actually a manual version. You can actually, these are some of the things that are available. Address to coordinates, Google style, coordinates to political areas, type of ward and district and things like that. If you look down here, I've got to ahead and put my address in here someplace, and you extract location. I get my home address. Here's my Latin lawn. I'm now going to here, and coordinates to statistics. I'm going to put my Latin lawn in here. And there's information about my zip code or my area. The way it does is it converts your Latin lawn to your zip code and then pulls the statistics on your zip code. So in my area, 0.4% is less than 4 years old. We don't have a lot of tours, although there's a lot of little kids in this neighborhood, especially on trick-or-treating next week. Number of households in the area, proportion of residents. This doesn't look, this looks bogus here. I don't know what you pay for. Actually, 0.44 meters. Height of surface area. Okay, that's high. But you can see all the things. You get temperatures by month. You get rain. Well, there's temperatures in Celsius. There's the right here, one for each month. Residents age 18 to 24. It gives you basically a breakdown proportion of different age groups and everything else. Now, it's great, and there's things like IP address to coordinate. It'll give you an idea of where you're located. Text. Where I went and use it was inside of R. And the code pretty much is you add the library, the R Data Science Toolkit, RDSTK. And then I just got a demo here. I put some Latin lawns in here. I have actually taken my data dictionary that I showed you in that spreadsheet, and I converted it to a CSV file, so I can run this against all of these. Now, there's actually 35 variables, but at 27 and 29, and a couple of these blow up. So I'm just going to run this and show you what pumps out here. And you get to see it's just running all the statistics that we saw on that previous screen. Then I can extract this and put it into a CSV file or into my data frame, and then merge it with my actual data set. So it's a slip, and it's quite fast. I mean, that was just one zip code or one area code, or correction, lat long. What it gives me, it's quite fast. If you have it running locally, it's even faster. So moving back to here. So that's just a sample of the code. Now, I'm not giving you these slides down so you can actually post them. The main one is this function right here, coordinates statistics, and I give it lat long, and then the statistic, one of those parameters you saw in that spreadsheet right here, one of these here, and then it converts it. And then I've got some little fancy, parsing here I've done to pull the parameter out. It's a little messy when it first works out, but free demographics, you can't beat this. All right, let me go on to the next one, because the second area I've been playing with is geocoding. And I have been camping out in Google geocoding. And the idea there is how do I convert Latin lawn to addresses? Mainly, I want to get zip code. And Google provides relatively free with a cost if you go beyond a certain number of queries, a geocoding data set. And they do reverse geocoding, and that's what I've been working with primarily. There's their address. Now, one of the things you do when you go out to geocoding is you want to get your own API key. And so on the geocoding website, you go to your Google Maps here, you get geocoding, you get reverse geocoding, and it's here that it's reverse. You have to get it gives you some sample codes, how to do it in different functions, Python, R. You can find all this on the internet that you want. Let's see, I want to get, mentions the key. Prices, let me just give you an idea. On prices, the first 25 queries per day are free. I also look at another site down at Texas A&M. but you get 2,500 credits, but it's a one-time shot. And after that, and you can submit a CSV file, and they'll send you back the answer. But again, it can get pricey if you have to start paying credits. Geocoding, if you stay under 2,500, is free, and that's what I've been trying to do, is stay under 2,500. And there's ways to do that. You can build your own little tables and things like that. If you run it to their website, and it's basically geocoding maps, and then what I stripped off here is the actual key that I've got, because I didn't want to put my key in here, because if someone hits it, they'll end up charging me. Or to get a key, you have to put your credit card in, and you just make sure you stay under your limits. But I put in a zip or an area Latin lawn here, and I basically get this text file here. It's JSON actually, but a number. This is out of my Chicago. This is New York actually. Gives you an area code right here, and that's what I've been pulling out primarily. But it gives you entire addresses here, plus Latin lawn and things like that. So it's a great tool to convert Latin lawns to zip code to addresses. And that's the code I've got for that. Let me show you a demo on that. Let's see. So I wrote for reverse geocoding, and I use the library RJSON because it's actually, you can get it in XML or JSON. I just found it easier to put JSON. And then I run this here, and I've got I got a lab here, and I run my function reverse geocode. Let's see if I can pull that here. And, oh shucks. Covered up my Skype. And it converts it to 60636, a zip code in the middle of Chicago. So these two functions give you great access to, one, converting lat lawns to zip codes, and then secondly, to convert zip codes to demographics in an area that you're focused on. And the good is the whole thing's free. Any questions?
Tom, can I ask you a question? This looks, you probably covered this already. This all looks like R code. Is that this?
Yeah,
is
it's
this
all
something
R code.
It all is?
Yeah, this is all R code, but the functions, as long as you can call a URL from your code. In my code here, I simply got, there's my key. But you can pretty much function, run this put it in any language. Python, the same thing all around.
Oh, I see. So what you're doing here is you're calling the URL from within R, but then you have that library. Yeah. But you have that library.
The library, I wanted to pull out multiple apps, and so what I did is, to make it easy, I created a CSV file of all the attributes, and also this is something I made it easy. And then I actually went down and did a parameter here. U.S. population, the actual parameter, is statistics.US population value. So I to parse out, of the JSON, the actual results. It gives you all those different lines, and I only wanted one thing. I wanted zip code. Oh, no, correction, I wanted one of these particular attributes. I run against all these attributes here, and I parse out a particular parameter out of the JSON up. It just makes it easier to convert to a file that I'll here on.
Wow. Yeah, I'd love to see all this stuff too. If you send it my way, then I'll post it for the other students. This is amazing.
Yeah, I tell you, William, on this data science toolkit, this tool is, for free. This guy did a fantastic job, and they try to maintain it. It's based on census data. And you can download your own VM, and that's where I get independence. I mean, I have my VM running at work now. I have a 16 gig machine, and it doesn't take 16 gig because actually the VM is only it's just an Ubuntu server, but most of it's the data set. You pull that 22 gig down, and you get the entire census data set it's available through those API calls.
Well, this is remarkable stuff. I can see a million uses for this. For heck, even I can, just personal projects I'm working on right now. I can think, this could come in handy. So I'm very appreciative of this.
Yeah, I wrote out to my analytics community in my company. I worked at Deloitte, and I said, who has any idea for a cheap or a free graphic site, place? And no one came up with anything. William gave me this site, and man, this is the best kept secret. I don't know why people aren't clamoring to get, to do this. And now that I've got my own copy, shucks, they can bring that site down for all I care. I've got a copy I'll run until the next census.
I love it. So, well, hey, Tom, thanks so very much. I think this is great. Now, also, I know that if I ever start playing around with this stuff, I know I'm going to come talk to you and William Kreckler, and hopefully you'll help me out. So, anyways, hey, listen, I'll stop the recording on this unless anyone has any final questions, and then I'll talk machine learning, and then we can call it a night.
Hey, this is William. I had a couple. So
Okay.
just to verify, you're running the virtual machine you downloaded as a guest, and then on the same PC, you could actually, in the host, run R and connect to it.
Correct. I do a local dot, I can HTTP local.8080, colon 8080
Okay.
is the link. You can set up your, I use Vagrant to set the image up. You can actually publish it to your network and then use it by other people in the building could call from it too.
Huh.
And you go to AWS and you can set up there and put it on the network. But if you do that, you get a free service and people start hitting it, you're limited to the number of pops or pushes and pulls you can pull it. Or gets and puts, and you can basically bust your budget. So I'm basically working on trying to get a virtual connection to my AWS service, and then I can do it just privately. But now that's on my desktop at work, I don't care. I can VPN to work and get it, remote. So.
Where's that thing that? Oh, I'm sorry.
Yeah, go ahead.
I was going to say, where's that thing that converted IP address to zip code?
It's on that Data Science Toolkit website. If you go here, let's see. There's this whole, it's a wealth of information. For example, there's IP address to coordinates. You type in your IP address and it gives you a coordinate. And again, it's estimating. It's how when you hit a website, sometimes it says, hey, you're in Chicago, or you're in, say for me, it's like Nashville. I live in Clarksville, but they think I'm in Nashville. Depends on your carrier. You can put in text here, and it removes parts of the text, boilerplate leading real sentences. Converts your HTML, shows you what it looked like. Does text, basic text analytics, or converts text to times, so it strips all the garbage and puts your actual date and time. But my main concern has been the latitude, longitude to demographics. So that's the main claim.
So lat long to zip, is it actually to the zip code based on the shapefile of the zip code, or is it like the hack that I did where it's based on distance and it chooses the closest one?
It's based on, best I can tell, on the actual zip code. Yes, it is. The best I can tell that I put in. Now, the trouble is trying to figure out. It's the problem. My first program I wrote was garbage. Now I'm getting back into my project, but I did a lat long. I did Pythagorean theorem from every one of my centroids. Well, quickly you realize you're goofed up because a big zip code area and a point real on the edge of that next to a small zip code area to be closer to the small zip code, and so it's going to throw your numbers off. So I actually I wrote a utility that took the centroid of each zip code area, went north, south, east, and west until it found the boundary and drew boxes, so to speak. It's kind of not perfect because some zip codes are oblong and kind of weird shapes, but I basically built boxes for my zip codes, and then I used that and an R code to take that lawn and figure out which box it fell in. And I had a 1.8 million record data set. It took me about 16 hours to run it. I started it in the morning and it finished that sometime that evening.
But that's for Chicago.
That's for Chicago, yeah.
Yeah. Wait, you had 1.8 million unique records?
Yeah. Well, they're unique. Some crimes happen at the same place over and over again. So, about 1.8 records through my archive that I set up for that. I could not have run against this. Let's see. Yeah, I would not have run that against, because here it is. The Data Science Toolkit takes zip, lat and long. I did not run all these against the Data Science Toolkit. I could.
Okay.
That would be horrible. I wonder how long to run. You got me thinking now. What I do is I convert the zip codes, and then I pulled, because this demographics is boxed by the zip code. When you look at these stats, I did some checking around, and the boundaries changed when you got to the edge of a zip code. These numbers flipped. They didn't flip until you get to the edge of the zip code boundary. So it looks like it's using census data based on zip code.
Okay.
So I converted all my events to the zip code for that area, and then I'm using and I got a demographics table I built on for every zip code in Chicago. I've got this demographics table. So then I just merged the two together, and I've got literally the demographics for every event. Does that make sense?
It does.
Messy, but that's why computers are they're so good. They do all the hard work.
So, okay, well, I'm gonna Tom, thank you very much, and William and Scott, this is great stuff, and I very much appreciate you guys giving your time. So if you send me your slides, I'll post them with everything else.
I'll do that. And William, I appreciate you putting me onto that toolkit.
Welcome. You actually used it more than I did, I think.
Well, you gave me the hook and the line, and